Today I will discuss about the runner and risers under unit 1, and end of this lecture the student will able to learn the types of functions and design of riser and also cleaning of castings. First I will discuss one of the important part of the casting system, gating system, that is the runner. What is the runner? Actually, runner is a horizontal channel or horizontal network in the gating system through which the liquid metal flow and also feeds to the mold cavity. Actually, the runner will start from the end of the sprue and it will end to the entrance of the gate, and just is a horizontal network or horizontal channel. Okay, and many types of runners are available, different types of runners available, and also different runners, also different cross sectional area also. Most common shapes are full round, half round, trapezoidal shape. That type of shapes are available as a runner type. Okay, so that type of shapes are most economic shape for flow of the liquid metal to the mold cavity. And also, if we provide any right angles or sudden changes in direction to the runner, if in the gating system, we know that is the horizontal channel. Okay, and then it will end to the entrance of the gate. Okay, and if that is the horizontal channel, any direction or any certain changes in direction or any right angles or anything will be provided to the runner, the flow of the liquid metal, it will be obstructed. So always we avoid the any direction in change or sudden changes or any type of right angles to that runner system. Okay, generally the cross sectional area changes direction from the sprue to the gate, and runner is reduced in its cross sectional typically about 25%. Okay, so due to use of that runner, we flow the liquid metal to the particular gating system, means to the mold. Okay, that is the runner. That is the one picture of the runner. We are seeing that is the pouring basin. Okay, and in that pouring basin, through the sprue, the liquid molten metal comes to that particular runner. That is the runner. That part is the runner. Okay, and to that particular runner, the mold cavity is connected. To the runner, the mold cavity is connected, and mold cavity is connected. That is the mold cavity. That is the mold cavity will be connected. Okay, so to that mold cavity, through the runner, liquid metal comes to that particular mold cavity. That is the gate. That is the gate. Okay, so here it will start from that end of the sprue. It will start from the end of the sprue and it will end to the entrance of the gate of that particular mold cavity. Okay, and it will sometimes ejector pins will be attached to that particular mold cavity for removal of the mold part easily from the casting, from the molding box. Okay, that is the fill up part of the molten metal. Okay, that blue color shows the fill up of the molten metal. Okay, so that is the produced part, that is the final produced part, means cast product. Okay, solidified product. Now we are coming types of runners. What are the types of runners? Now already I have told three types of runners we have used. Full round runner is the efficient shape for reducing the cooling effect on the material at flow through the passage and it will come to the particular mold cavity. Okay, when the liquid metal flow through the runner, it does not freeze to the runner section. Otherwise, molten metal does not come to the mold cavity. So, Always liquid metal maintain its pouring temperature for flow of the liquid metal through the runner section. That is the cross sectional area of the runner. That is the cross sectional area of the runner. The red color shows the cross sectional area of the runner. Okay. So if we consider that is a molding box, the upper part of the molding box we know cope and the lower part is called drag. Okay, and in between that two parts lying the parting line. Okay, and that is the plastic flow, means flow of the liquid metal, means that is the cross sectional area of the runner. Okay, so that is also efficient shape for reducing the cooling effect, means that shape will help to reduce the cooling rate. Okay, means it will reduce the cooling rate, means it does not solidify to the runner section. If it will take the solidification, the flow of the liquid metal will be diverted to the runner passage. Okay, so always it will that type of shape also economical shape that will reduce the cooling effect of the flow liquid metal. Okay, another half round runner also, that is also a good shape that also reduce the cooling effect, and also it will help the flow of the liquid metal in the proper way to the particular mold cavity. Another trapezoidal runner, that is also one of the common shape, and also the flow of the liquid metal also controlled through that particular trapezoidal shape runners. Okay, and that also one of the economical shape for flow of the liquid metal to that particular shape. It is the cross sectional area of the trapezoidal shape. Okay, na? Okay, that is the trapezoidal shape of the cross sectional area of the trapezoidal shape. Okay, just we show the cross sectional area of the trapezoidal shape which maintain as a runner. Okay, that is the plastic flow, means liquid metal will flow through that particular passage. Liquid metal, that is the liquid metal which is flow through that particular trapezoidal shape passage. Okay, and that is the parting line that is considered as a molding box. Okay, now we are coming to gate. Gate is the small area between the runner and the part cavity. Sometimes gate will be, some parts of the gate will be kept to the drag side and some other parts also to the cope side, and in between that two parts the parting line will be lie. Okay, so the type, size and location of the gate in an ejection mold is critical efficiently producing the cavity parts. Means actually gate is a entrance of the liquid metal to the mold cavity, means through which liquid metal will enter to the particular mold cavity. Okay, and the type of gate select depends on many factors. Okay, what are the factors? Gate witness marks, that what are that thing? Material type, filler, if we use any type of filler, that also depends upon the type of the gates. Generally we do not use that thing. Okay, material type, filler, tooling cost, and some shape allowances, scrap allowances we provided to that particular liquid molten metal, because we know if we provide the liquid metal to the mold cavity, after solidification some extra space will be generated, means some allowances will be generated to that particular mold cavity when it will take solidification. Okay, a single gate per cavity is desired. How the part size and the material used may be dictate multiple gates also used sometimes. Sometimes we use the multiple gates for multiple mold cavity, and at the same time using sprue plug, the molten metal will be flow through that particular mold cavity and different parts will be produced using casting process. The gate location and the surrounding area is also highest area stress in the final part, and also position due to gate function indicates bending or impact strain is required. So in that cases, some factors which affect the gate system. Now we show the types of gate. What are the types of gate? First, edge gates. So in that cases we see that the different types of plastic part means it will produce part when through the liquid molten metal. Edge gate. So here we say so that that is the runner, and through that runner the liquid metal will come to that particular mold cavity. Okay, and here we have seen that is the edge gate, means from the edge of that, means that is the one edge part of that particular mold cavity, and at that edge part we produce the gate. Okay, produce the gate at the edge part, we produce the gate, and through that gate the liquid metal flow that particular cavity. Okay, means after coming the liquid molten metal, it will take solidification and finally the product will be produced using casting process. Okay, that is the edge gate, means most commonly used for all gating options. Okay, and also the height of the gate should be equal to 7 to 100% of the wall thickness, up to we are taking 0.125 inch. Okay, and the width should be the width of that particular gate, it will be equal to 2 times of depth. It will 2 times of depth. It appear in the mold. The depth of that particular gate, that will be equal to 2 times of the depth. Another is fan gate. That is the also one of the type of gate. Okay, through which we provide the plastic means molten metal we throw through that particular gate, means type of the gate as like fan. Okay, that what is the utility of that fan type gate? That minimizes the backfilling and provides a better part surface. Means backfilling means it will does not back to that particular passage, means runner or screw, means it will go in one direction. Okay. Now fan gate will leave the scar size of that particular cross sectional area, means in that particular fan type gate what happens? Now provide the scar the size, means leave a scar the size, okay, cross sectional area, and requires manual trimming from that particular runner. Sometimes it will, that scar size will be created, and sometimes trimming is required in that particular gate also. Now we are coming to pin gate. Pin gate means in 3 plate molds, means 3 parts, means scope, drag and parting line. So in that cases, when we provide the gate, the entry of the liquid metal acts like pin shape, and through that pin shape the diameter varies from 0.30 to 0.100 diameter. Actually varies from, gate diameter varies from 0.030 to 0.100 diameter. It will vary, and a pin gate will leave a small car. Okay, small car that will be size of the gate. Okay, so in that cases the shape of the gate, that is as like pin type, and through that pin type gate the liquid metal will flow to that particular mold cavity. Okay, another a ring type gate, means that is the shape of the ring type gate, that is the pin type gate. Okay, that type of gate scar will be created. Okay, now ring type gate means the shape of the gate as a ring type, means that is the feed runner, okay, and through that runner the liquid metal will come to that particular mold cavity, means it will come to that particular ring type gate, okay, and that is the cross sectional area of that, particular ring type gate. Okay, means the entry of the liquid metal, it will goes through the ring type gate. Okay, means different type of gates we are discussing. Okay, and will produce a scar around, means scar type will be produced to the use of that ring type gate. Okay, the height is equal to the gate height, and also a scar around the entire part, the height is equal to the gate height. Okay, so that is a ring type gate, that is the pin type gate. Another is a sprue gate. Sprue gate means sprue type gate, that is the sprue gate we are discussing. When sprue gate is when single cavity, one single cavity we are taking, so in that cases cavity cylindrical parts need to be balanced and concentric. So in that cases sometimes we are taking sprue type gate. So in that gate the cavity must be single cavity cylindrical parts. So in that cases we are drawing that type of sprue type gate. We are provide the shapes sprue type, and in that particular shape we flow the liquid metal a single type cylindrical type cavity. Okay, then it will take the solidification and other process also going on using that type of sprue gate. Another is shaft gate is there. Main gate always we are taking, and sometimes we providing some extra gates, means extra shaft gate we have provided to that particular gating system. So what happens now, getting away from the parting line can be accomplished by the use of shaft gate. Means if we are considering that is a parting line, in the parting line, across the parting line or along the parting line we provide the gate. Sometimes beyond that we provide some extra gate, means that is called shaft gate, and through which also liquid metal coming to that particular mold cavity. Okay, and the shaft gate also provide for automatic degating of the runner and part within the mold. Also some extra gate, means shaft gate we provided, and some extra part to that mold cavity also produced using that particular shaft gate. Means type is cashew, banana gates require the split inserted steels. That type of gate we have used. That type of materials used for providing the shaft type gate. What is the riser? Already I have told, riser is a material, liquid metal reservoir, means also act as a feeder system. Means in that particular system the extra metal will be stored. Okay, when shrinkage will takes place to the casting product, to the mold cavity, in that time the extra metal will be feeding to the particular mold cavity for compensation of the material. Okay, means is a reservoir built into a metal casting mold to prevent cavities due to shrinkage. When shrinkage will takes place, so in that time we provide the extra metal, means riser acts as a feeder or reservoir from which the extra metal goes to that particular mold cavity. What are the function of the risers? First of all, provide extra metal to compensate the volumetric shrinkage. Okay, means due to shrinkage, means after solidification the extra space will be created, and for compensating the extra space the extra metal goes to that particular extra space that will come from the riser. Another, allow more gases to escape. And also riser, sometimes riser upper part of the riser, that is also sometimes that is the open space, and through that open space easily the entrapped gas to that particular mold cavity that will be emerge out. Another, provide extra metal pressure. It will sometimes provide the extra metal pressure, because sometimes the liquid molten metal freezing. So in that cases it will sometimes provide the pressure for flow of the liquid metal to the entire part of the mold cavity. Okay, easily for filling the entire part of the mold cavity it will sometimes provide the extra pressure. Okay. What are the types of risers? Already riser are categorized based on the three criteria. Means where it is located, another whether it is open to the atmosphere or how it is filled or how it is closed. Okay. Criteria first is when it is located, where it is located, and whether it is open to the atmosphere or and how it is filled. Means first is top riser. So in case of top riser, it will located on the casting. Okay, and then it is known as top riser. And in that cases, sometimes we provided the some side riser, side things to the next of the castings, means side of the casting. Sometimes we provide the side riser also. In case of riser is open to the atmosphere, so in that cases it is known as a open riser. Means riser, upper part of the riser, no extra part is there. Okay, means it will fully open to that particular atmosphere. That is the open riser. Another is blind riser. Blind riser means it will completely contain into the mold. Means it does not open to the particular atmosphere. Means the riser is completely contained in the mold. It is called blind riser. Okay, it is called blind riser. Now, open riser is usually generally bigger size in case of blind, because the open riser loses more heat to mold through the top of the riser. It will losses more heat because it is open to the atmosphere. So easily heat will be extracted from the liquid metal. Now we are seeing that different type of risers, that is the top risers. Top riser means in that cases we are seeing that it will open type, means here the upper part will be open to the atmosphere. Okay, that is the mold cavity. That is the mold cavity, and here we have seen that that is the riser, and in that system that is the pouring basin of that getting system, and that is the sprue, and some that is the sprue well, and that is the runner part, and here riser is open to the atmosphere. Okay, another is that is the side riser. That is the side riser is blind type riser, means the upper part of that particular riser does not open to the atmosphere, means that is the blind type. That is the blind type riser. Okay, means here the extra metal comes to that particular mold cavity, that is the mold cavity, and that is the sprue, and upper part is basin, and that is the sprue well, and that is the runner. Okay, and upper part is scope, and lower part is drag. So in that particular picture we are seeing that that is the top riser and that is the blind riser. It is also called side riser. What are the requirements of the riser? First one, riser size. First one, the sound casting riser must last to freeze. Means when the liquid metal comes to that riser, it will does not freeze. Means it will freeze at the last time of that casting. Okay, means the ratio of the volume of the surface area of the riser must be greater than that of the casting. Means maybe extra metal is required. So that's why the ratio of the volume of the surface area square must be of the riser must be bigger than the casting. That is very important condition. Another, riser placement. The spacing of the riser in the casting must be considered effectively calculating the feeding distance of the risers. Means the distance of the position of the riser and position of the mold cavity, means in between that two distance, means feeding distance must be also calculated. If feeding distance from the riser to mold cavity is more, so in that case sometimes extra metal does not come to that particular mold cavity. So In that cases, we must be calculated the feeding distance. Okay. Third one, riser shape. So different type of shapes are there, but which type of shape is economical in case of riser? Cylindrical type riser are recommended in case of casting process. That type of shape will be most economical, is the most economical for providing the extra metal to that particular casting process. Cylindrical type riser is the most economical shape in case of riser. What is the cleaning of casting? After production or after casting, the final product we have got using the casting process, then some extra metal, some debris, some impurities are stick to that particular product. So it is required for removal of that particular debris from the casting process. It is mandatory. Otherwise, the outer shape, outer surface finish of that product, it will not good. So in that cases, we have taken from the molding box, then we finally we are taking some using air blasting or water blasting. First we remove the some debris from that particular casting product. Then sometimes maybe extra bars or extra depression, some wire tear maybe happen to that particular product. We using some machining process, some finishing process, grinding, turning or some other finishing process, we finish the particular product to that particular cast product. Okay. After finishing, we get the actual dimensional product. Okay. And also the surface quality of that particular product also good. Means by the cleaning of casting, finally we have got the particular finished product. So in that casting process, the cleaning operation usually performed on a casting in given below. What type of things we have removed? First one, removal of the gates. In gates, riser, feeder, runner, screw and also other things must be we removed, and also molding box also we have removed. After that we have done trimming and finishing operation, means machining operation we have performed in that particular product for getting the final good quality product. So removal of the gates, in gates, riser, feeder, everything we have removed for getting the final product. Okay. So in that cases, various methods of removal unwanted metallic part from the solidified casting product. Different methods are there. First we have removed the molding box, sad material. Then we have removed the riser, feeder, gate, screw, that type of things we have removed. Then finally we do the finishing operation. After finishing operation, we have got the accurate dimensional product. Okay. What is trimming? Trimming means some unwanted extra part to that particular product we have removed by trimming operation. Some unwanted extra part. So how we will remove? By using some grinding operation or some turning operation, means some using machining operation we remove the some extra part. Okay. Means involves the removal of the fin, gate, risers, metallic chaplets. So then these unwanted material is removed by using hammer or chisel, that is called chipping process. Sometimes also using some machining process also we remove some extra parts also, means some unwanted extra part we have also removed. Another is finishing. Finishing means final cleaning, means final shape we have provided to that particular product. How we will remove that things? Now using some grinding operation or turning operation. Okay. Sometimes some sand will be stick to that particular product, that also we have removed by using some cleaning process, by using some brush. Using that brush we have removed that type of some impurities, debris, something parts we have removed. Okay. Means that is the some using machining process, means conventional using some conventional machining process we remove some extra parts, and some polishing process is there, some buffing process is there, some chemical treatment using sometimes some chemical also we remove some extra part also, means some unwanted parts. Okay, that is the finishing operation. What is the inspection of the castings? Means in that cases various characteristics, means the required surface finish, the dimensional accuracy, everything is good or bad, means everything is accurate or not. We have measured that dimensional accuracy using some measuring scales or some measuring instruments we have used for final taking the final measurements. Means using that, means if we have required diameter is something, as we let us think that is the 30 millimeter if required. So it will, that diameter of any type of cylindrical part, that is 30 millimeter or below or upper. So we have measured using some measuring instruments. So after finishing we inspect them, the dimensional accuracy is good or bad. Okay. But what are the various inspection process? That is the measurement of the final dimensions, means using some measuring instruments. Another measurement of surface finish instruments also there, means every surface finish, magnitude of the surface finish also provided to that using some instruments. Another destructive testing and non-destructive testing. Using that testing also finally we have decided the product is good or bad. And end of this lecture, students have learned types of functions and also design of the riser and also cleaning of the castings. How they cleaning the final product which is produced by the casting process. So in that particular gating system we have seen that is the gating system, and in that gating system what happens, that part is the runner part, okay, and that is the sprue part, okay, and that is the pouring basin, means pouring cup, and that is the sprue base oil, and that is the another gate, means from the runner the liquid metal comes to that particular mold cavity, okay, means that are the gate, okay, and that is the riser, means it will act as a molten metal reservoir, means here extra liquid metal will be stored here. If it will take any type of shrinkage to that particular casting product, so in that, due to creation of extra spaces, extra allowances, the extra spaces in that particular product, the extra metal will coming from that riser. Now we are seeing that the first part is the pouring cup, means it is called pouring basin, and in that, through that pouring cup we pour the molten metal taking from the ladle, and pouring molten metal will be made to the any type of furnace, generally cupola furnace. That is the pouring cup. Then another part is sprue, and at the end of the sprue well is connected. Means initially after coming the pouring molten metal in the sprue well, it will stored, then it will go to the runner. That is the sprue base oil. That is the sprue base oil. Runner. That is the runner. Runner will be connected to the sprue base oil. That is the different parts of the gating system, and to the runner the different gates will be connected, and through that gates the liquid molten metal comes to the particular casting process. Means different pattern also, different mold cavity also created for different gates. Also we are taking very large type mold cavity, means in that mold cavity we have connected different gates also, means number of gates we have connected for flow of the liquid metal, for heavy type of, for huge type of flow of the liquid metals also easily flow to that particular mold cavity. more amount of material will be flow through that mold cavity, and in that mold cavity we have connected to the riser, means extra metal we have added, means stored to that particular riser. When the any allowances, shrinkage allowances takes place to that particular mold cavity, the extra metal is coming from the riser to that particular mold cavity for compensating the extra metal. That is the final thing, and different parts, means ideal parts of that particular getting system, or different parts of the mold system.